So last term we looked at a few index laws and we're going to continue on with more indices. This term we're going to look at some negative indices and we'll see they actually come out of one of the simple index laws, the second law that we ever learned. So let's start with that second law. Let's say I've got 6 to the power of 8 divided by, you might remember, like say 6 to the power of 5. Well, they've got the same base, so what I can do is just subtract the powers. 6 to the power of 3, or 6 cubed. And that works pretty well. But what happens if this second index is larger? Let's say I've got 4 to the power of 7 divided by 4 to the power of 11. Well, 7 take away 11 is negative 4. Now, I would be asking you at this point whether you think you can actually write that. But the answer is that you can. 4 to the negative 4 is a legitimate answer. But we just need to understand what it actually represents. And to do that, we can have a look at a descending list of 2 to the power of something. So let's try 2 to the power of 3 in expanded form is 2 times 2 times 2. 2 to the power of 2, or 2 squared, is 2 times 2. To get from here to here, I divided by 2. 2 to the power of 1. Well, again, I divided by 2. You might remember when we were looking at 2 to the power of 0, why does that equal 1? Well, you can see if we keep dividing by 2, 2 divided by 2 gives us 1. Let's say I was to keep going this time. 2 to the power of negative 1. Well, let's divide by 2 again. So I get 1 divided by 2, or half. 2 to the power of negative 2. I'm going to divide by 2 again, because that's the pattern, that's how we descend. 1 over, well, what's half divided by 2? It actually gets us a quarter. 2 to the power of negative 3. I'll divide that by 2 and I get 1/8. Now, you might, if you're kind of doing some of the sums in your head, notice that this number here is the same as 2 squared. This number here is the same as 2 cubed. So what we end up with is when we've got to the power of a negative, it actually becomes 1 over 2 squared. And instead of negative 3, 1 over 2 cubed. That means we can write the law that looks like this. X to the power of negative m equals 1 over x to the positive m. That's the law that we're kind of looking at today. This can also work in reverse. Let's say I've got 1 over x to the negative m. Well, that's the same as x to the power of m. So when you're flipping an index, I should say, from the bottom of the fraction to the top, you change its sign. Or from the top of the fraction now to the bottom, you change its sign. So that's the important thing to take away from today. When changing an index from numerator to denominator, or brackets, or vice versa, the other way around, you change its sign. Brackets, just to remind us positive or negative. So let's have a look at some examples and how that plays out in practice. So a question might read something like this. Write with positive indices. And let's say it was 3 to the negative 8. Well, easy one to start. I need to write this with positive, so I need to change the sign of negative 8 to just be 8. So I know I want 3 to the 8, but because I'm changing the sign, it has to swap from the top, because remember this is all over 1, from the numerator to the denominator. So that's my answer, 1 over 3 to the 8. Now let's do it with some algebra, because that we could obviously just type in a calculator and it's no point in doing it. But let's apply it to some algebra. Let's say I've got x to the 3 and y to the negative 4. Alright. Now, this x to the 3 and this y to the negative 4 are both on the numerator. But one of them has a negative index and we want positive. So let's change that to a positive. But when we change the sign, it flips over to the denominator. So x cubed stays where it is. That doesn't need to change. The sign is positive on the power. It's going to stay positive. And then y to the 4 needs to flip to the bottom of the fraction. Alright, let's try another one. Select my pen color. There we go. Don't know why that takes so long, but it has been taking a while. Let's have a go at this one. Let's see. Let's say 4 over x to the power of negative 3. Now we're combining the law from last term at the very end. So I'll just quickly go over it now. When we've got a fraction, all to the power, this power applies to everything in the brackets. So this could be written like this. And now I need to combine it with the law from today by making it positive. So to make this a positive 3, it needs to flip. Currently it's on the denominator, it goes to the numerator. This one's on the numerator, it goes to the denominator. And there you have it. It is now in positive. I could even then be super fancy and kind of take the power of 3 out of the brackets again, the cubed out of the brackets again. But both of those are fine. Both of those are correct. Let's have a go. Let me find one more real interesting question. Alright, let's do this one. Let's say 2 m to the negative 4 over n to the negative 5 and c to the power of 2. Well, first of all, what's really tempting to do is connect this negative 4 to the 2, but it's not. There would be brackets around them if it were, but we don't have those. So this only applies to the m. So what I need to do is leave the 2 on top. That m to the 4 is going to go underneath. I've changed the sign and flipped it onto the other side of the fraction. On the bottom we've got an n to the negative 5. Well, that's going to go up top and become positive. C squared, that's already positive, so it stays as it is. And there you have it. That is negative indices in a very short amount of time. So if you have any questions, come make sure you pop in on the Zoom chat and ask me, and I'll gladly go through them, as well as any questions from last term or over the holidays that might have come up. Thanks.